Hey, welcome to the channel everyone. In this video we're going to be going over the basics of differentiation. Differentiation is a form of calculus and it has many different uses. The main purpose of what we're going to talk about today is differentiation essentially allows you to find the rate of change or the gradient at any given point on any function, and it doesn't matter if it's cubic or quadratic. Non-linear differentiation will find you the gradient at any given point. So, for an example, let's say we had on our Cartesian plane y equals the natural log of x. That function is going to look something like this, and what the derivative does is lets you find the gradient and the rate of change at any given point on this graph. So let's say if x was equal to 10 and you wanted to find your gradient, what your gradient formula says, m equals delta y over delta x, or rise over run basically. So with this function we run into a problem because we can't do that. Because it's non-linear, so you can get pretty close, like x equals 9.9, and take those 2 points there. That will give you a rough estimate of your rate of change, but it's not going to be accurate, because no matter how close you bring these points in together, this function is non-linear, so you're never going to have 100% accuracy using the old method to find your gradient. So this is where differentiation comes in. Is this part of calculus? Differentiation, essentially, theoretically, you're dividing by 0. And I know this sounds silly, but this is the theoretical side of calculus. And this is why it's so good, is because you can do things that you can't normally do. Like if you had a exponential function, like technically you're never going to reach that 0 point, but it's going to keep getting closer and closer, right? And I hope this gives you a fair idea of what calculus and differential calculus does. Is essentially lets you divide by 0 so you can find limits and you can find your rate of change at any given point. I know this can be hard to understand, but let's go over a quick example. So say we were given the function y equals 3x squared minus 5x plus 4. Now this is a quadratic function, so let's say we were asked to find the turning point or the minimum point on this function. We know this quadratic is going to look something like this. And from that, you don't need to graph this, by the way, but I'm just showing you to represent it. And we're going to use differentiation to find the minimum point on this quadratic function, right? How might you do this? So, what do you notice about this? This is the tangent, but what's special about this is the gradient m at the local minimum, or the turning point on this graph, is going to be equal to 0. As you can visualize, that it's not changing by anything when you're on this point here on the graph. So you're going to have no gradient here. This is useful because when we take the derivative of the function, we can then sub the value in to find where on the x-plane and the y-plane this minimum or 0 is equal to the gradient. And what this is going to do is let us find the turning point or the local minimum on not just this function but any function. This is just a basic quadratic function, so we're going to start off with this. So your basic differentiation rules, and I recommend writing these down. These are very important to remember especially when you're going into exams, you don't want to have to be searching through formula sheets wasting time. So make sure you remember this. Make sure it's clear in your mind so you can do this easily. And let's start off with your basic differentiation rules. So we have the function y equals 3x squared minus 5x plus 4. What differentiation does, and this is the rule behind it, so make sure you're copying this down. The derivative of this function we're going to denote as dy dx. And this is also equal to y dash or y prime. And there's many different ways that people write these, so just make sure you're familiar with these. But the two main ones you're going to see is dy dx and y prime. We're going to stick with dy dx for this video. And this just means this is the derivative of the function. So, what the power rule says is we take the power to the variable, which x squared. We're going to bring the power down. We're going to have 2 multiplied by 3. Then we're going to have x. And we're going to take 1 from the power. So that's going to be 2 minus 1. So what the rule does, you take the power, you multiply it. You bring it out front, you multiply it by the constant. And then you take 1 from the power. This is the most basic differentiation rule. And when we do this, we're gonna get minus 5 times, and you know this x is gonna have a 1 to the power of 1 technically. We just don't write that down. So when we find this, we're gonna do minus 5 times 1 x, and then we're gonna have 1. We're taking 1 from the power, 1 minus 1. And when you get to this constant, because it has no variable attached to it, this is just going to go to 0. So this is the basic differentiation rules. We multiply by the power, and then we take 1 from the power, and when there's no variable attached to a constant, it just goes to 0. It doesn't matter how big it is, it always goes to 0. So from this we get dy over dx equals, we're going to have 6x, and 2 minus 1 is just 1. You can just leave that, but I'll write 1 there just to make it look a bit more simple. Now, minus 5 times 1 is just 5. And then x, and anything to the power of 0 is just 1. So 1 minus 1, 0. X to the power of 0 just turns into 1. Multiplied by minus 5 is just minus 5. So what we have done, we have found the derivative of the function. And once we found this, what we then need to do, due to the question, we're looking for the turning point. Now, as I said before, at the turning point, your gradient m is going to be equal to 0. So, we found this, then we're going to do 0 equals 6x minus 5. And the reason we do this is because your derivative just represents your rate of change. So we can sub different m values in, and then find your corresponding x value. So for this, we're going to sub 0 in, because that's where your local minimum is going to be, because there's going to be no rate of change, it's just going to be 0. And then the next step is to solve for the x value where the rate of change is 0, or the local minimum on this quadratic function. We're simply just going to solve this function. So we can bring the 5 over to the other side, equals 6x. So you know x is going to be equal to 5 over 6. And this is approximately 0.83. So now we've solved our x value. This is the value where the rate of change is going to be 0. So we've solved our corresponding x value to the local minimum of this quadratic. So we can write this is going to be equal to 0.83. And this is x, and this is y. And to solve for your y value where the rate of change is 0, what we're going to do, we've already solved for the x value, so we can simply just bring it up here and sub it back into the original function to solve for y. Y equals 3. We're going to leave this as improper fractions, just to keep our accuracy when doing this. So that's going to be y equals 3 times 5 divided by 6 squared minus 5 multiplied by 5 divided by 6 plus 4. I'm going to type this into the calculator and we'll see what we get. So we're going to have 3 times 5 divided by 6 squared minus 5 times 5 divided by 6 plus 4. And this gets us an approximate value of y equals 1.92. And this is all we need to do. We've solved both our x and y value for when the rate of change is 0. So we know y is approximately 1.92 and x is approximately 0.83 when the gradient is 0. So what we have done, we have solved our local minimum on this quadratic function. This is the lowest value that y can take, and because of the nature of the quadratic, you just set your gradient equal to 0. That's always going to find you your local minimum and also maximum points, depending on whether you have a cubic function, a quadratic function. Doesn't really matter. It's always just going to find you your turning point. So that's the basic introduction to differentiation. So I hope you can tell that it doesn't matter what m value we set, we're always going to find the rate of change at any given point. And this is so useful for many different reasons, but mainly for when we have a function that we can't just do our normal gradient rule on, we can take the derivative and find an exact value to the function. So now you've seen what differentiation is used for, and this is very, very basic, by the way. This gets a lot more advanced with differential equations, partial differential equations. We can be looking for the turning points on very big functions like cubics, and then you don't know which is your local minimum and maximum. There are ways to find that by using your second derivative rule, but we're going to learn that in a different video because this is just going to be a basic introduction to differentiation. So the power rule, and right now I'm just going to go over some rules because you can get many different functions like log functions, trig, like exponential. So we're just going to be going over the basic rules on what you need to do when differentiating a function that is presented to you, that contains like logarithmics, exponentials, like you name it. So we're going to do the power rule. So these are your power rules to differentiation. Sorry, not power rules. We'll just do these are your differentiation rules. So we have the power rule, which says if you have x to the 5, we'll say 5x to the 5, then we know the derivative y dash, that's the same as dy dx, is going to be equal to, we're going to have 5 times 5 x 5 minus 1. And that's your power rule. So you multiply by the power, then you take 1. So that's going to be 25x to the 4th. And if you keep running through this, you can find your second derivative is going to be equal to it's going to be equal to 100x to the third. Third derivative is going to be 300x squared. Fourth derivative, 600x. And we can keep going. And we'll eventually get to 0. So this is your basic power rule. When differentiating a function, you just multiply by the power, then you take 1. So I hope you understand that now. And this works for a lot of things. And if you have to the power of 1, then it's just going to become 0. And anything to the power of 0 is 1, so you just have your constant left over. And any constant goes to 0. That's your next differentiation rule. And let's look at something a little bit more complicated. So if we had an exponential, so we have y equals e to the 2x, when differentiating this function, for your exponential differentiation rule, it says that your derivative is going to be equal to, what we do here, we have to find the derivative of the power, and this is only for e to the power of something. Only use this rule for an expo. We're going to find the derivative of 2x. That's going to be 2. The derivative of 2x is 2. And we're going to multiply that out the front. And unlike your power rule with constants, when it's an expo, the power is not going to change. So we're going to leave that as 2x. Doesn't matter what it is, your power will never change when taking the derivative of e to the power of anything. It's never going to change. So all you do is you multiply by the derivative, and then you leave your power the same when presented with an e. And if you had y equals e, ex equals the derivative of x is just 1, so that's just e to the x. I hope you're getting the hang of these, and it doesn't really matter what it is. You're looking for the derivative in the power, bring that out the front, and let's do one more example. Y equals e to the power of 4x squared plus 2x plus 3. And for this one, it's very important when you're finding the derivative, make sure you put brackets around your derivative. Because we're multiplying by the whole derivative, not just the last part of the function. And the derivative of this power up here, we're going to have 4 times 2 is going to be 8x plus 2. Alright, so we found our first part, the derivative, and then the second part, so this is why you make sure it's in brackets, is just because you want to make sure you're multiplying the e by everything inside those brackets, so you don't get confused. And then the power is just going to remain the same. Plus 2x plus 3. And this is your derivative. And that's the same rule for any exponential function, alright? Next up, we're going to look at what the derivative of a logarithmic function. So, firstly, we're going to say the derivative of ln x. How do you do this? So, the derivative of ln x is just 1 on x. You can write that down, that's just a basic rule, just remember that. That's what ln x derives to. But what if you got ln to the 2x? That's just going to equal 1 on x, and then multiplied by the derivative of the inside bracket. Just like your exponential function. This is also known as your chain rule, or the shortcut to the chain rule. This is what we're doing here. But we'll keep it simple. Multiplied by 2 equals, that's just going to be 2 on x. So that's your logarithmic rules. Alright. And it doesn't matter what function you get in the brackets, you're just going to do 1 divided by, and then your inner function, then multiply the fraction by the derivative of the inside bracket. Alright, so next up, we're going to look at your trig rules. We'll say we have cos of x. This is going to differentiate to negative sine of x. And sine x is going to differentiate to cos x. They're your trig rules, are your basic ones, and it gets more complicated than this when you're looking at a tan function or a cotangent. There's so many trig rules, but we're just going to look at your basic cosine and sine functions. And the same again, if you had y equals cos of 2x, derivative is going to be equal to, we're looking for the derivative inside the bracket, 2 multiplied by, and cos of 2x is going to differentiate to negative sine of 2x. So that's your basic rules for your trig functions, your basic ones. And this is just an introduction video, so we're going to keep it simple. And next up, we're going to look at the shortcut to the chain rule. Where's your chain rule useful? Whenever you get a function where you have something inside a bracket to the power of something, and that can look like, we'll say 5x squared plus 4x plus 2, then we'll raise that to the power of 3. What your chain rule says, very similar to what we were doing before with some of the log and trig functions. We're going to multiply by the power, and this is different to your power rule. It's very similar, but it's different in a few ways. So make sure to copy this down and remember this. We're going to have 3 times, and again we're going to look for the derivative of the inside bracket. That's going to be 10x plus 4, and then we're going to multiply by the entirety of the inner bracket. That's going to be 5x squared plus 4x plus 2. And then we're going to take 1 from the power. So you can expand this out if you want, you can leave it, doesn't really matter, just make sure it's simplified enough. And this is, we'll just expand out the first bracket, and this is just going to be 30x plus 12, and this is all going to be multiplied by 5x squared plus 4x plus 2, and this is just squared. That's your chain rule, and it's going to be the same to anything. It can be more complicated, but your rule's always going to remain the same, right? Next up, what we're going to be looking at is your product rule. This is useful, your product rule, if you get a function where you have 2 unknowns, but they're a product, hence the name. So let's say we get x times cos of 2x. When using your product rule, first what you need to do, you need to make a table. We're going to have u, v, v dash, u dash. So that's the first step. Just write that out, because we're going to be substituting and manipulating the equation to find the derivative. So we're going to have a table, u, u dash, v, v dash. We're going to set u equal to, doesn't really matter, just a function, x, and v is going to equal cosine of 2x. And u dash, x just differentiates to 1, cosine of 2x differentiates to negative 2 sine of 2x. And when we're using the product rule, once we've got this table, we're going to cross multiply and add them together. So it's going to equal, we're going to have u times v dash. That's going to be minus 2x sine of 2x. Then we're going to add next function on. We're going to have cosine of 2x times 1, which is just cosine 2x. So make sure you practice your product rule, and this is the same for any product. Just remember, try and spot these when they come up. Can save you a lot of time from expanding things, so this is quite useful. And the last, like, kind of basic differentiation rule which you need to know is going to be your quotient rule. As the name suggests, when we're presented with a quotient or a fraction, this is where we need to use the quotient rule. So when the fraction contains unknowns on like the numerator and the denominator, this is where we need to use the quotient rule. So if we get 5x squared, and then we're going to divide it by, we'll just do 3x plus 2x. For your quotient rule, again, we're going to set out a table, u dash, v dash. We're going to set u equal to the numerator, which is going to be 5x squared. U dash, differentiate, 5x squared becomes 10x. V equals 3x plus 2x. So we'll just do 3x plus 2. And then v dash is going to be equal to, that's just going to differentiate to 3. And your quotient rule says that your derivative is going to be equal to v times u dash minus u times v dash, all divided by v squared. So make sure you write that down. That's your formula to the quotient rule. And it's important to make sure you multiply the right way. Unlike the product rule, it doesn't matter. When we're doing the quotient rule, it does, because we're taking away. So make sure that you do this in the right order. So first up, v times u dash is going to be 10x multiplied by 3x plus 2. And then we're going to be taking away u times v dash. 5x squared times 3 is going to be 15x squared. And then divided by v squared, 3x plus 2 squared. That's your quotient rule, and this is what you need to remember. This is pretty basic stuff. This is just your normal product, quotient, and the shortcut to the chain rule. I don't see any point in learning the full chain rule unless you're doing it for like related rates of change and stuff like that, which we'll go over later. We're just going to keep it basic for now, so I'd just say learn the shortcuts to the chain rule. It's much more simple, much more basic. So this is all you need to know for basic differentiation. And yeah, once you found this is why it's useful, is you can solve for different things. On quadratics, you can find turning points, and to end the video, let's do one more example. So let's say we have a function of x is equal to x cubed minus 6x squared plus 9x plus 2. And this function's a bit more tricky, alright? This is a cubic. And this is going to be a lot more challenging than what we've done so far, because we're going to solve for both turning points. And we don't know what the function's really going to look like. Probably something like this. I know it's not, the drawing isn't great, but we're going to solve for it. And say we were asked to find both turning points. We're going to have a local minimum and a local maximum. So when we set our derivative equal to 0, just remember that you're going to end up with a quadratic. And remember, when solving quadratics, that you're going to have two solutions. And this is because there's going to be a max and a min. There's going to be two turning points on this cubic function. So remember that. So let's find our derivative. Y prime is going to be equal to 3x squared minus 12x plus 9. And let's solve for our derivative. So we're gonna have to set this equal to 0. 0 equals 3x squared minus 12x plus 9. And you can either factorize this or you can use the quadratic formula. I'm just going to use the formula. I can't be bothered right now to factorize this. But if you want to learn how to factorize and solve that way, just drop it in the comments and I can make a video about it. We're just going to use the formula for now. So we're going to say x is going to be equal to, we're going to have 12 plus or minus, and then we're going to have minus 12 squared minus 4 times 3 times 9. That's all going to be divided by 2 times 3, and this is going to be squared. So let's plug this into the calculator. We have 12 plus negative 12 squared minus 4 times 3 times 9 divided by 2 times 3. So when we have 12 plus that function, when we're adding, we're going to have x is equal to 3. And when we're using the negative, we're going to have or x is going to be equal to 1. So we've drawn the function wrong. Alright. And this is because we know x equals 1 and x equals 3. This is going to be our 2 turning points. So it could look like this, or it could be the other way around. And we're going to use differentiation to solve for the nature of the turning points. And this is going to be the most complicated part that we've done this video. And we're going to end on this. You've solved for your turning points, but you want to know which is your max and which is your minimum. This is just a rough sketch that I've drawn. I don't know if it looks like that or if it's the other way at the moment. And we've got our derivative up here. What you need to do when you're finding the nature of the turning point, you're going to find your second derivative. And that's pretty simple. All you have to do is differentiate this function once more. So that's going to differentiate to 6x minus 12. And when you're doing this, what we're going to do next, we're going to have x is either 3 or 1. So we're going to set both x's and we're going to solve for those. So we're going to have 6 times 3 minus 12. That's 12. Sorry, that's 18 minus 12, which is just 6. And then we're going to have 6 times 1 minus 12. And that is just minus 6. Alright. And once we found these, so you sub your x values in. Once you found those points, we're going to know, since this is positive, it's going to be a local minimum. And we know this is negative. This is going to be a maximum. So that's how you solve for your nature of the turning points. So you know at x equals 1 it's a maximum, and x equals 3 it is a minimum. So let's draw that in the graph. Oh, looks like we've got that right. X equals 1 is a maximum, x equals 3 is a minimum. So we've solved for both our turning points, and we know the nature of the turning points. So we've done most of the hard work. Now the last step is we need to set y equal and just find the y points of the function. So we're going to have two solutions. Y equals 3 cubed minus 6 times 3 squared plus 9 times 3 plus 2. And y equals 1 cubed minus 6, 1 squared plus 9 times 1 plus 2. I'm just going to plug this into the calculator to save some time. X equals 3, y is going to be equal to 2, and x equals to 1, y is going to be equal to 6. And I have drawn this a little bit wrong. And we can plot these. So our maximum at x equals 1, y is going to be equal to 6. This is your maximum. And at x equals 3, y is going to be equal to 2. And this is going to be your minimum. So we can say the function is going to look something like this. And this is how we solve for a cubic function, and this is the rules of differentiation. So we've solved for both our turning points, and this is so useful. It allows you to find your turning point of any function, your rate of change of any function, and has so many more applications to it. Especially in engineering, fluid dynamics, you have differential equations, you can model the way planets are going, predict the weather as well. Has so many applications, and this is just the basics of differentiation. So hope after this you're going to remember the rules of differentiation, and thanks so much for watching the video, guys. If you have any questions or video requests, please leave it in the comments below and give me any advice on if there's anything I need to change with teaching this, if I can make it easier for you guys. I really want to just put you guys first and build you guys up with this and see you guys do well in maths. So let me know if there's anything you want to change. Please just be positive. I really appreciate it. And always remember, Jesus loves you and I love you too. And you can do all things through God who gives you strength. Always remember that. And good luck with your studies. I'm sure you'll do well. Have a great day, and I'll see you next time. Bye.